Okay, just to start off again, okay, because I started recording late. What we were doing when we counted 10, we looked at the difference between a height of this and a height of this. We looked at the difference, and mathematically, that equals subtraction. Same with here. In the run direction, we were looking at what the horizontal difference is between the 6 and the -4. It's going to involve a subtraction. So keep that in the back of your mind, because once we flip our page, you will see our formula. There's going to be a difference happening. Let's try this one. Once again, if you were to calculate a slope, what you're trying to do is identify a triangle. This point looks pretty nice. That is point what? -2, -4, because x comes first. And this looks pretty nice. That is 2 and 4. What is my slope? Let's backtrack. What is my rise? How high did I go? Let's try. So it started with a height of -4 and went all the way up to +4. So 2, 2, 2, 2. I went up by 8. What about my run? 1, 2, 1, 2. I went to the right by 4. My slope is 2. Here's the thing. What if we didn't have a graph? Does that mean we're stuck because we can't count boxes? Again, what we're doing with the graph is a subtraction. You just didn't really see it yet. Or maybe you do. I'm not sure. But whenever you are in doubt, you can use a formula that I have for you in the next page. The key idea is this. If you are able to identify any 2 points on the graph, just like here, you notice how we always identify 2 points? We identify 2 points. If you can identify 2 points on the graph, all you have to do is set them up so that the y values are on top, the x values are on the bottom, and you find the difference. That's it. So let's take a look at this. Example. In this example, I have a point that goes through 5, 6, and if you want a visual, 5, 6 is around here, let's say, and -3, 2 is around there. I want to know what the slope of those 2 points are. Instead of looking for a way to count the graphs, you don't even need this. What you can do is set up an equation where it's, I'll do it by color, blue. My 5 is the blue, it's the x value. My red is the 6. And my -3 is the blue, my 2 is red. Okay? I'm placing my y value on top, and I'm putting my -3, my x value on the bottom. And then I subtract. I am placing the y value of 6 on the top, and I am placing my x value of 5 on the bottom. 2 minus 6, -4, -3, -4, 5, -8. But you might not have followed that very carefully, so I'm going to show you one more time. And this time, I want to let you know it does not matter what order of points is used. What I'm trying to say is take a look. My -3, 2 was placed first. My 5, 6 was placed second. This time around, I'm going to say that my second point is the 5, 6, and my first point is my -3, 2. All right. So Let's do this. M equals, get here please. M equals long line. What's my second point? 5 and 6. My 5 is the x, it goes on the bottom. My 6 is the y, it goes on top. Okay? Minus, minus. I'm going to just do that. Yes.
This is like you're using another graph to plug points on.
It's the same 2 points, and I want to show you whether I do the -3, 2 first or the 5, 6 first. It's going to be the
Like
same.
the points are like points coming from a graph somewhere. Like they're
Yes,
not there.
correct. So it's the question is this: a line is passing through these 2
Yeah.
points.
You said the order doesn't matter. Does that mean it doesn't matter if the 2's first and the 6's first, or it doesn't matter which number is
Well, the x is still on the bottom, and the y is still on the top. But as long it doesn't, what I'm saying is it doesn't matter if I use this plot first or if I use that point second.
So could it be 6 minus 2 on top?
Yes, this is what I'm doing. So 6, so 5 and 6 is right here. And then -3, 2, the -3 is the x, so it goes on the bottom, and a +2 is y, it goes on top. So 6 minus 2, 4. 5 plus 3, 8. Da, 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 da. Same as before. It does not matter if I do 1 point first or the other point first. You will both get the same slope because you're talking about the same line. So let's try it. Continuing on. I have a point -2, 5 and -5, 4. M is equal to long line. Just follow with me, even if you're not quite there with us. Just follow along. M is equal to a long line. X goes on the bottom, Y goes on the top. Think about it. X goes on the bottom, Y goes on the top. Do it. -2 is on the bottom, 5 is on the top.
Wait, so like why is x first like on in like when you put it in like brackets comments, but then it's like on the bottom? Does it matter?
Remember from previous lesson, it's always a change in Y over the change in X.
Yeah.
So that's why we're putting the X value on the bottom. Now, subtract, subtract. With me? Let's use a second point. X is on the bottom, Y is on the top. I'll give you 5 seconds. -5 is on the bottom, the 4 is on the top. If you solve it, 5 minus 4, 1. -2 plus 5. -2 plus a 5 is a +3. There's your slope. Do it one last time. Oh, question, yes.
So with x and y as I
You can use whichever point you want first. Here, let me color code it. I am color coding the first point, -2, 5, and you'll see it right here. Right? And then -5, 4, you see it right here. You can do red first, is what I'm saying. And I'm going to get you to do that in example practice number 1. So we'll see. M. Draw a long fraction. We're going to use 4 and -8 first. X is on the bottom, Y is on the top. I'll give you 5 seconds. Four is on the bottom, and -8's on the top. Minus minus 2, negative 2. X is on the bottom, Y is on the top. I'll give you 5 seconds. Two is on the bottom, and negative 2 is on the top. Solve that, it becomes negative 8 plus a 2, 4 minus 2. My slope is negative 3. Go ahead, ask away. Anyone? Questions? Okay, I'm going to ask you to test it. In the practice one right beneath, I give you the same points. I want you to switch the order and see if you get the same slope. Please switch for practice B. Example 1 or practice 1. Sorry. For practice 1, I want you to switch the order of the points and see if you get the same slope. In other words, please test it if I gave you the points negative 5, 4 and negative 2, 5. Feel free to ask questions. Let's move it around. So in other words, instead of this order, I would like you to do negative 5, 4 and negative 2, 5.
So negative 1 over negative 2.
Wait, could we just answer as a fraction? One over 3 is 7.
Yeah. But I want you to know that you'll see something funky going on, but it's going to be the same thing. I'll give you another minute to see if you can apply the formula. And notice something interesting. Notice a relationship between the example that we did just now. As you can see, this formula is very mechanical. It's just plugging in numbers and pressing an equal sign, which means there's a lot of room for carelessness. Please be careful that you don't make mistakes plugging in numbers. And this is why I'm trying to take my time with it. Write your n, write your equals, draw a long line. X is on the bottom, Y is on the top, minus, minus. X is on the bottom, Y is on the top. 4 minus 5 is negative 1. Negative 5 plus a 2 is a negative 3. And if that works out, negative divided by negative, you can actually simplify that and say that's a positive 1 over 3. It's a little bit of an extra step, but I wanted to show you that it doesn't matter which order you do it, you should still get the same number. That's what I expect for part B. Okay, I'm going to do this portion first. X is on the bottom, Y is on the top, minus, minus. X is on the bottom, Y is on the top. Negative 2 plus 8 is a 6. 2 minus 4 is a negative 2, and so I get negative 3. Please notice the numerator has a negative this time. Over here, the denominator has a negative, but either way, you get the same answer. This is our key idea. The following examples that I have is simply me going through the different styles of questions, like what if I give you a t-table? What if I give you a graph? But the key idea is this formula. If you can do this formula with a t-table, if you can do this formula with a graph, you're set. That's all it is. Let's take a look at example 2. All right. To do formula, to use slope, I need 2 points. Give me 2 points. When did we add today? For slope, the special operation is if
subtract.
Yes,
Perhaps you get just 2 numbers.
that's a good question. Well, it says that this is linear. So I know this is a straight line. And if I want to do slope, I need 2 endpoints. 2 endpoints. So choose them for me.
-2, -2.
Okay, that's one of my points. So I will call this my -2, -2. Give me another one.
2.
Okay, that's my other point. That's going to be 2 and 4. Calculating the slope equals long line. X is on the bottom, Y is on the top. Minus, minus. X is on the bottom, Y is on the top. As you can see, I've been saying this for quite a while because I have multiple grade math classes. X is on the bottom, Y is on the top. Minus, minus. X is on the bottom, Y is on the top. Right? So the point -2, -2 comes from the first point right here. Minus, minus. Subtraction of a +2 and a +4 comes from the second point right there. Yes.
Isn't
Yes. So -2, -2. Does that work? I think the shapes sort of help, right? Am I wrong? The shapes work? The shapes help with your eyes? No? No? Am I crazy? Let's keep going. We've got -2 - 4 is a -6. -2 - 2 is a -4. Once again, negative with negative. This is a +3/2. That's my slope. So it's your turn. I'm going to give you, I'll say only a couple of minutes for both. It shouldn't take you longer than that, really. Choose 2 random points and see if you can calculate slope. Choose 2 random points. See if you can calculate slope. I will randomly choose someone after and ask me to give me their, ask them to give me their 2 points. And do an example. Let's see. I don't know. Who can I ask? It's been a couple of minutes. Elliot, can you choose 2 random points for me? Which one would you use? 210? 210? And one more. Okay. So let's call this one point number 1. We'll call that point number 2. M is going to be, let's do point number 2 - 1. We've got X on the bottom, Y on the top. Minus, minus. X on the bottom, Y on the top. -2 - 10 gives me a -12. 8 - 2 is a +6. So my slope is just -2. Someone else want to offer me their random points? Patrick, choose 2 points for me. -8 and 10. Give me another one. 7 and 1. Okay. Taking that, let's call this point 2, and let's call that point 1. M is equal to X on the bottom, Y on the top, minus, minus. X on the bottom, Y on the top. 10 - 1 is a 9. -8 - 7 is a -15. And if you reduce it, you get yourself a -3/5. That's it. So Previous page, we calculated slope when you had just some random words. Example 2 right here, you found the slope when you were given a t-chart. Example 3 underneath, you're going to find, you're going to look for the slope using a graph. Or you're going to graph it, or I guess we're going backwards. We're going to try to relate what we know using a graph. Clearing this, let's go down. Please take a look. A line segment has one endpoint. Edit. I realize this is not going to give me the best graph because it goes off the chart. Can you turn this into a 1, 1, 1? Let's turn it into a 1, 1. Anytime you see A, we're going to use the point 1, 1. So method 1, 1, 1. Method 2, 1, 1. Okay, there's 3 different places. I like you to replace it with 1, 1. Because the graph is, it's going to be a little bit off. And so I think it's just more useful that way. Okay, everyone. This time they give me a point and they give me a slope. In other words, they tell me what my rise and run is. Here's the problem. My slope is -5/3. Which number is the negative? The rise or the run? Who says the 5 is actually a -5? Who says the 3 is actually a -3? Who has a different answer for me? Who doesn't know? The answer is either or is okay. If you set the rise to a -3, that means my run is a positive. This is also equal to a positive rise with a negative run. And let me show you why that makes sense. Please find the point 1, 1 and draw a little circle. Let us use, I'll do this in blue. I'm going to use the -5/3 as my slope. -5 is my rise. What does that mean in terms of moving on the graph? My rise is -5. I'm going down. So 1, 2, 3, 4, 5. And my run is positive. So 1, 2, 3. So -5 and +3. Okay. Let's go the other way. What if one of you chose 5/-3? What's my rise in this case? 5. So I'm going to go up by 5. 1, 2, 3, 4, 5. And what's my run? -3. So what direction am I moving? A run is -3. So if I move to the left by 3, does that look like a single line to you? Yeah. So a -5/+3, a +5/-3, it doesn't matter. Find the coordinates of another possible endpoint B. Sure, I can say that a point exists as 4, -4. I could also just as easily say that -2, 6 is one of those points, which means you say therefore 4, -4, or of course, -2, 6 are possible endpoints. For B. What if I wanted not as a graph? Can you use the coordinates and create a t-chart? Let's start with the point 1, 1. Your peers are a lot more immature than you are. Let's talk about it. So this is my X, that's my Y. Let's do the blue. I'm coloring it in blue. What's my rise again? -5. What's my run? 3. Which one is the -5 going to be involved with? Yes. So can we subtract a -5? And then can we add a 3? What are my two coordinates? -4 with a 4. Hey. I'll use red this time. My rise is a 5, my run is a -3. So what if I have a rise of a +5 and I have a run of a -3? 1 + 5? 6. 1 - 3? -2. Hey. Yes. The question says that you have 1, 1. So I'm starting with the point 1, 1.
Yeah.
From there, my slope is -5, 3. So that means my rise was -5. So I'm going to see what happens if I subtract -5. And my run is a +3. So I will add a 3. And I get to this point right here. And in the same way, if I use the other slope, which is essentially the same thing, my rise is a 5, +5. My run is a -4. So I added a 5 to my y, I subtracted a 3 to my x. I get this coordinate, which happens to be right there. The whole point of me doing this and getting a little more annoying with you is that I want you to see no matter what angle you go through, we're talking about the same thing. There's multiple ways to approach this math. Some ways might be easier to you than others, but it's all talking about the same thing. And I hope that very soon you'll be very comfortable with all forms. Which brings us to practice 3, which I will stop for the day. Practice 3 gets you to practice this, practice example 3. Following that, there's a bunch of independent practice. And as you can see, the amount of homework that I'm giving you, if you haven't done so already, is starting to pile up. I hope you'll give yourself an opportunity to work on the slope stuff, especially since I'm not seeing you tomorrow, over today and tomorrow night. You'll be able to practice this and become very comfortable talking about linear equations when we start dropping dolls from the ceiling. Yes. Yes.
Are you gonna be checking the call on Friday?
No. All that time will be devoted to the assignment. And as I said before, I'm not sure if it was this class, but we're basically more than halfway through semester 2. If by now if you have not developed a habit of crack opening your homework at home, then you're already behind other people who have developed that habit. You gotta be able to do it. Or make like some people in this class, like that was like me. In grade 12, this is a shameless story. In grade 12, I happened to have math in first period, algebra. And I had a prep or a spare in second period. I refused to take that math textbook, which was really heavy, home with me in my backpack. And so just because I didn't want to carry something heavy, I finished all my homework every day in second period during my prep. It just so happened that it helped me and it helped me get a good mark. But if you know you won't be able to do any math, or you have other obligations, like you have lessons or you've got clubs or you've got other things to do, finish it early. Try to finish it quick. Learn to be efficient. Do whatever you need to do. Okay? So have about a little over 10 minutes. Hope that you'll be at least willing to finish practice 3 and start some of the homework practices, maybe every other question. Anything you need to ask before we call it a day? All right, let's get to work. Yeah.